One of the most captivating cosmic phenomena is the possible supernova of Betelgeuse. It is a popular red star located in the shoulder of the Orion constellation. Betelgeuse is a crimson supergiant nearing the conclusion of its life cycle. Unexpectedly, in 2019, one of the most luminous stars in the sky began to dim noticeably, visible even to the unaided eye. For several months, its radiance diminished to such an extent that numerous observers speculated whether the star was dying. Aiming their telescopes at the massive star, researchers were amazed by the evidence. The significant dimming of Betelgeuse is thought to signal it may be on the verge of erupting into a supernova, marking the conclusion of its stellar existence. But when and why will this cosmic detonation occur? Could it pose catastrophic impacts for our planet? The radiant scarlet star Betelgeuse is positioned on the upper right shoulder of Orion the Hunter. You might know it by a different name, Alpha Orionis. Despite being the second most luminous star in that constellation, following the supergiant Rigel, it continues to intrigue scientists due to its fluctuating behavior and distinctive moniker. Alpha stars are generally the brightest within their constellations. Although Rigel surpasses Betelgeuse in brightness, Betelgeuse draws attention due to its enormous size and reddish hue. Betelgeuse, also referred to as Alpha Orionis, ranks among the most renowned stars in the night sky, being the 10th brightest and 7th most visible from much of northern Canada, Europe, and the United States. Its designation is derived from Arabic and signifies the armpit of the giant, referencing its spot in the Orion grouping. Betelgeuse loses approximately 1 solar mass every 10,000 years, releasing material uniformly in all directions and generating a nebula surrounding it. This nebula spans 30 astronomical units, or 30 times the distance between Earth and the Sun, and is 250 times more massive than the star itself. At its core, Betelgeuse's hydrogen nuclei merge under immense gravitational pressure, creating helium and emitting radiation and heat. As the star depletes its hydrogen, it begins fusing helium and carbon. When helium runs out, neon combines with carbon to yield iron. The fusion of iron, however, fails to produce energy, leading the star to collapse under its own gravity and ultimately explode into a supernova, one of the most powerful explosions in the universe. Depending on their age and developmental phase, stars emit light in a variety of wavelengths, from the vivid blue of youthful stars to the red of older ones. Based on ancient astronomer Ptolemy's observations, Betelgeuse exhibited a hue he intriguingly labeled ruddy. Nevertheless, early Chinese astronomers remarked that Betelgeuse looked yellow, hinting that it may once have been a yellow supergiant. Massive stars rapidly burn through their hydrogen, leading to an early demise. Even if they last only 10 million years, there's no question that Betelgeuse is in its final phase. While our Sun still has more than 5 billion years of life, Betelgeuse is approaching its last moments, meaning it could someday erupt in a supernova. However, the precise timing of this event remains unknown. Betelgeuse experiences 2 cycles of brightening and fading, one happening every 5 years and lasting around 100 days. It's believed that the expanding and contracting of its outer layers during these cycles causes changes in its diameter and surface temperature. Widespread interest in Betelgeuse surged during its unpredictable behavior in 2019 and 2020, when its light faded dramatically before recovering briefly. Certain scientists have theorized that this strange activity could indicate the star is nearing its final transformation. Comprehensive study of Betelgeuse dates back to the 1st century BC, yet the cause of its dimming remains a mystery. Betelgeuse has been observed moving through the interstellar environment at about 30 km per second after being ejected from its birthplace in the Orion OB1 group, which includes the stars of Orion's belt. The resulting bow shock extends beyond 4 light-years. Measuring the distance and size of red supergiants like Betelgeuse is notoriously difficult in astrophysics, as various elements interfere with accurate diameter estimates. Moreover, since it is a pulsating star, Betelgeuse's size varies over time. This characteristic, combined with the dimming of its outer edge, causes its observed brightness to shift and diminish when seen from Earth. Additionally, the shell of material expelled by the star plays a crucial role in light emission and absorption, also affecting how we interpret its brilliance. Observing Betelgeuse is difficult because the wavelength of light influences its apparent size. These measurements can vary by up to 35% depending on the part of the spectrum used. In July 2009, the European Southern Observatory released visuals taken with the Very Large Telescope Interferometer, VLT, at its ground-based observatory, revealing a massive plume of gas stretching up to 30 astronomical units from the star. This enormous plume of gas, likely ejected from the star's surface, provided unprecedented insight into the violent and complex life of red supergiants like Betelgeuse. These outbursts suggest that mass loss in such stars is not always steady or symmetrical, but rather happens in fits and bursts, fueled by dynamic processes occurring deep within the stellar interior. In addition to visible light observations, astronomers have also studied Betelgeuse in the infrared spectrum. These studies reveal that much of the star's expelled material forms thick, dusty clouds, which further obscure its light and contribute to the irregular dimming events observed from Earth. One particularly dense dust cloud, formed by a major ejection in late 2019, is believed to have temporarily blocked a significant portion of the star's light, causing the so-called Great Dimming that captivated both scientists and the public. While a supernova explosion of Betelgeuse would be a cosmic spectacle unlike anything in modern times, scientists reassure us that it would pose no threat to Earth. The star is located approximately 640 light-years away, well outside the kill zone of a supernova's harmful radiation. Instead, such an event would offer an extraordinary opportunity for astronomers to observe the birth of a supernova in real time, with potential breakthroughs in understanding stellar evolution, neutrino physics, and the synthesis of heavy elements. Should Betelgeuse explode, it would become so bright that it could be visible during the day for weeks, possibly even casting shadows at night. Its brilliance would eventually fade over time, leaving behind a remnant, possibly a neutron star or black hole, and a supernova remnant nebula that would shine for thousands of years. For now, Betelgeuse continues its erratic rhythm of pulsation, brightening, and dimming, with astronomers keeping a constant eye on its behavior using the world's most powerful telescopes, both ground-based and orbiting in space. Each flicker, each pulse, could be a sign of the final countdown or simply another quirk in the complex life of this massive, aging star. The mystery of when Betelgeuse will explode remains unsolved, but its story continues to illuminate the delicate and awe-inspiring life cycle of the universe's most massive stars. Surface: one of many mass expulsions seen from Betelgeuse, this outflow matched the angle of separation between the Sun and Neptune. At least 6 such events have been found around Betelgeuse. These occurrences may provide insight into the question of mass ejection in the concluding periods of massive stars, which may be central to their destruction. The complicated processes within Betelgeuse's extended upper layers remain puzzling, as does the exact method by which red supergiants cast off their matter. Such stars are fundamental to the circulation of elements within galaxies, and due to progress in interferometry, astronomers are approaching solutions to these riddles. In 2019, scientists employing the Hubble Space Telescope and other observatories found that Betelgeuse had blown off a considerable portion of its outer shell, triggering a substantial surface mass ejection, SME. Though the Sun creates solar mass ejections, Betelgeuse's events were thousands of times more extreme, with this theme flinging out material 400 billion times heavier than the average solar eruption. This explains why Betelgeuse suffered a steep drop in luminosity in October 2019. By mid-February 2020, it had lost nearly 3 times its brightness, shifting from magnitude 0.5 to 1.7. By February 17, 2020, Betelgeuse's brightness had stayed largely constant for more than a week. On the 5th, it appeared that the dimming had stopped completely. Until recently, reductions in visible light weren't connected to a probable core collapse, as no notable changes in infrared radiation were registered on February 24, 2020. Feel free to share your thoughts in the comment area. If you appreciated this video, click the thumbs up icon and subscribe so you won't miss future content like this. When Betelgeuse ultimately detonates as a supernova, it will be among the most dramatic cosmic occurrences ever documented. Even at the blast distance of 640 light-years, it will shine so brightly that it could outshine the full moon and even be seen during daylight for several weeks or even months. Experts estimate that the supernova will discharge more energy in mere seconds than our Sun will emit throughout its entire 10 billion-year lifespan. The illumination from the explosion will speed through space and eventually make it to Earth as a magnificent pinpoint of light unlike anything we've witnessed before. But rest assured, we are entirely safe. Although a supernova that near may sound threatening, Betelgeuse remains distant enough that the detonation will not harm Earth's biosphere or living beings. What it will do is present an extraordinary scientific occasion. As of the last few years, Betelgeuse has been back to typical levels of brightness, but its irregular dimming patterns are still under intense observation. Scientists are leveraging tools like the James Webb Space Telescope, the Hubble Space Telescope, and land-based interferometers such as the VLT and ALMA. They are tracking surface light fluctuations, patterns in convective activity, and continual mass outflows that seem to reflect the star's instability. One well-supported idea is that Betelgeuse's notable dimming was brought on by a vast cloud of starborn dust, created during one such eruption, momentarily veiling the star's light from our viewpoint. Grasping the mechanisms behind Betelgeuse could assist astronomers in decoding the life phases of gigantic stars, particularly those close to undergoing supernova. Such insights could help forecast similar phenomena in other galaxies, explain how chemical elements enrich the cosmos, and detail the formation and scattering of elements like iron and gold throughout space. Betelgeuse is effectively a ticking cosmic timepiece, and it's winding down slowly. It may explode tomorrow, next year, or in 100,000 years. But whenever it does, it will present a galactic spectacle, and a wealth of scientific data, unmatched in modern times. The mystery surrounding Betelgeuse has inspired astronomers, physicists, and even amateur skywatchers to keep a vigilant eye on its behavior. In many ways, it has become a case study in real-time stellar evolution, a front-row seat to the dramatic finale of a red supergiant's life. Recent modeling suggests that the star's interior convection currents are more turbulent and uneven than previously believed, causing irregular surface motions and sudden energy releases. These surface instabilities may be precursors to more significant transformations, such as the buildup to a core collapse supernova. Moreover, Betelgeuse serves as a laboratory for testing advanced astrophysical theories. Observations of its magnetic fields, pulsation patterns, and spectral shifts provide crucial data for understanding how stars distribute mass and energy into the surrounding interstellar medium. What makes Betelgeuse especially intriguing is that it's close enough for us to observe in incredible detail, yet still far enough away to pose no danger. With each new burst of data, scientists refine their models of how massive stars end their lives, models that can be applied across the universe, from nearby dwarf galaxies to the furthest reaches of deep space. As the international astronomical community continues its watch, coordinated efforts between observatories are intensifying. Space-based platforms work in tandem with ground-based arrays, forming a global network to ensure no critical event goes undetected. While the exact timing of Betelgeuse's supernova remains uncertain, the anticipation continues to grow. Whether it's years or millennia away, the star's eventual explosion will mark a once-in-a-civilization moment, a cosmic finale visible not just through telescopes but with the naked eye. Until that day comes, Betelgeuse will keep offering its lessons, in patience, in curiosity, and in the relentless drive to understand the vast and powerful universe we inhabit.